All right, let's jump right in and talk about something really cool called edge compute. We're going to explore what it means to run your code not in some faraway data center, but right at the edge of the network, super close to your users. It's a game-changing idea, and it solves a surprisingly tricky problem. And that problem is a real head-scratcher. Picture this. You need to add security headers to every single thing your site sends out. But what about the stuff that's cached? Like an image that gets served to someone in Tokyo directly from a server in Tokyo. Your main server, maybe all the way over in Virginia, never even sees the request. So how on earth do you modify a response your server never touches?
So, let's set the scene. Meet Timothy. He's a developer, and he's just been given what sounds like a pretty simple task. A new compliance rule says they have to add 2 new security headers to all of their web traffic. Easy enough, right? He immediately starts cooking up a plan.
And you know, his plan makes perfect sense. Of course you'd go to the backend code. That's where all the logic lives. He figures he'll just tweak the main Lambda functions and boom, every response that goes out will have the new headers. Job done. Or maybe not.
Just then, his mentor, Margaret, chimes in with a really important question. She points out that they use a content delivery network, or CDN, to make the site faster. And that's where Timothy's simple plan hits a major snag. So, here's the deal. When a user in London asks for a product image, the CDN is smart. It doesn't travel all the way across the ocean to Virginia. No way. It just serves up a copy it has stored locally, right there in London. We call that a cache hit. It makes the site blazing fast, but it creates our problem. Timothy's backend code never runs. And if the code never runs, those security headers are never added.
Okay, so we can't just turn off the CDN. That would make the site slow for everyone. So what do? Well, this is where it gets interesting. AWS actually lets us run code at the edge, right inside the CDN. And we do this by hooking into what's called the CloudFront request lifecycle.
You can think of any request as having 4 key moments, 4 places we can jump in. First, there's the viewer request. That's when a user's browser first hits CloudFront. Then, if it's a cache miss, we get the origin request. That's CloudFront asking our backend for the file. Third is the origin response. The backend sends the file back to CloudFront. And finally, the 4th and final step, the viewer response, when CloudFront sends everything back to the user.
Now here's the breakthrough. We can run our own code at any of those 4 points. For Timothy's problem, since we want to add headers to everything, including those cache hits, we need to run our code at the very last second, right on that viewer response trigger. This is after CloudFront has grabbed the file from its cache, but right before it sends it to the user. That's our moment.
So to get this done, AWS gives us a couple of amazing tools. We've got Lambda at Edge, and we've got CloudFront functions. Both let you compute at the edge, but they're built for very different kinds of jobs. It's all about picking the right tool for the task at hand.
Let's break them down. Think of CloudFront functions as a scalpel. They're tiny, super lightweight JavaScript functions that run in less than a millisecond. They're cheap, they're fast, but they can't access the network. Perfect for simple things like changing headers. Then you have Lambda at Edge. That's the sledgehammer. It runs full Node.js or Python, can make network calls to other APIs, and do all sorts of heavy lifting. But it's a bit slower and costs a little more.
And Margaret nails it. She says, look, all we're doing is slapping a couple of headers on a response. We don't need network access. We don't need heavy compute. What we need is speed, pure unadulterated speed. And for that, CloudFront Functions is the clear winner.
So with their decision made, Timothy gets to coding. And what's so cool about this is how beautifully simple the solution is, especially for what feels like such a tricky problem.
And there it is. That's the entire fix. It's not some huge, complicated application. It's just a handful of lines of JavaScript. The code simply says, hey, when you're about to send a response, just pause for a microsecond, add these 2 headers, and then carry on. That's all. It's so simple, it's brilliant.
So the code is written. Timothy attaches the function to their CloudFront distribution, telling it to run on that viewer response trigger, and he deploys it. Now, for the moment of truth, let's see if it actually worked.
Timothy pulls up his browser, clears his cache, and requests a product image that he knows is cached in Tokyo. The result? 12 milliseconds. 12! I mean, that's literally faster than you can blink. It's proof that the function ran without adding any delay that a human could possibly notice.
And then the final check. He opens up the developer tools to inspect the response. And bingo, there they are. Both security headers attached perfectly. The code ran at the edge in Tokyo, modified a cached file, and solved the problem without ever bothering the main server. Mission accomplished. So
Let's zoom out a bit. What did we really learn from Timothy's story? It's a perfect example of why global compute is so powerful. Let's make sure we've got the key ideas down.
First up, edge compute. At the end of the day, it's just about running your code in the right place. Instead of a single central brain, you're putting little bits of intelligence all over the world, right next to your users. This means lower latency and incredible control over your web traffic.
The hero of our story today was CloudFront Functions. Just remember this: if you need to do something simple, but you need to do it millions of times a day with basically zero performance hit, this is your tool. Think URL rewrites, header changes, all that good stuff.
And don't forget its bigger, more powerful sibling, Lambda at Edge. This is what you'll reach for when you need more firepower. When you have to call another API, check a database, or do some really complex logic right at the edge, Lambda at Edge has got your back. Knowing how to use these tools really does change how you can think about building fast, secure, and smart global applications. The possibilities are huge. So, the only question left is, now that you know the secret of the edge, what are you going to build?